Now, hello everyone. This is 4.2 linear systems. Linear systems, using another word, we also could say linear functions. Functions. Okay, let me explain what's going on here. In the previous chapter, chapter 6, we are very used to how to solve a linear equation. Now, it's not a linear equation anymore, it's a linear functions. So this is basically two big parts in algebra study. Okay, now algebra, we could say equations, that is for solving for x to find the value of x, or we can also say functions because we want to see how x and y works out between them, the relation. So equation, it is something you have an equal sign, right? So then you have 3x equals to 6. Therefore, the x as a variable cannot vary anymore. You only have one value to make this 3x equal to 6, which is 2. So we have done many more, much more complicated equations rather than compared to the 3x equal to 6. You've done beautiful work with these complicated equations or even complicated inequalities. Now, functions. Now, all of a sudden, we have two variables. Note, we have two variables here. See? One is x, one is y. So what does that mean? Well, I would later on explain by telling a story. But after all, that means this variable and this variable. Now, two variables here. See here, only one variable, just x. Here we have two variables. One is x, one is y. So that means they're in the relationship with each other. They cannot be different random number. Now, for example, if x equals to 1, y cannot be negative 4 because they're bounded by this equal sign. So if x equals to 1, so let me take a look, make a chart. If x equals to 1, then y equals to 3. Now, x equals to 2, y equals to 6. So in this case, x can be random numbers, but y cannot be random numbers because they have this relation. But in other words, it could be y equals to 1. Randomly, I just pick y. Now, how much is x? If y equals 1, now x equals to 1 over 3. Right? Now, if x equals to 3, y equals to 3, sorry, then how much is this chart has to be going longer? So then if y equals to 3, then x equals to 1. So they're in this relation. Now take a look at this one. This is called coordinate system. Another thing I want to call this is called the Cartesian plane. Oh my gosh, my Cartesian plane. I don't really know what's going on with my writing pad. It happens many times, it's very frustrating. Okay, so what happens here? This is the Cartesian plane. It's invented by a French mathematician and a very famous philosopher. His name is René. I think French got it this. And Descartes. So without him, we wouldn't even have this Cartesian plane. The Cartesian plane is, this is x-axis, now this is y-axis. Every single point on this plane will have a coordinate called ordered pair. So it will have an x value and it has a y value. What does this mean? Is you go down to x-axis, there's a value, which is here, and you go to your y-axis, and that's another value here, and this is a y value. Okay, so now take a look at this. If the ordered pair is given, then you can plot these values on the dot. Plot the dot on the Cartesian plane. X 0, 0 is right here, 0, 0 is right here, and 3 and 2. So x value is 3, y value is 2, so it's right here. And also, if a point is given, you can also read the x and y value. Now let's take a look at exercises here. So the exercise is here. So you can, if this is the a, then it's -3 and 1. So x value is -3, which is here. Y value is 1, which is right here. So plot the point. So then this is a point A, right? Now, find the coordinates. Now, for example, now how about this B? The coordinate of the B, x value, so we draw down to the x-axis, is right here. 1, 2, 3, 4. X value is 4. Now, what is the y value? So we go to the y-axis. So 1, 2, 3, 4, 5. And then that is 5, right? So that's how you do these two questions. Now, because now we have the Cartesian plane, so that means now we're trying to figure out the relationship between x and y. Now, a linear equation, now we're talking about equation, a linear equation. What mean? That means you still have, so it's not linear equation, it's not just x plus 3 equals to 5. It's not like this anymore. There's a y here. So we talk about linear, it is x to the power of 1. So in this case, is y now equals to x plus 3. All right? Now, as far as this is a power of 1, this is a linear equation or linear function. This means the function between x and y in a very special relationship that determined by this x, by this equal sign. Now you can have y equals to negative x minus 3. You can have y equals negative 2x plus 1 over 4. You can have y equals to 2 over 3x plus 5. You can have a whole bunch of things. So in this case, if we generalize them, that means there's a coefficient -1, the coefficient -2, the coefficient is 2 over 3 for all x value. So we can just say y equals to m. M can be any number, x, and now plus 3, -3, plus 1 over 4, plus 5, and this could be considered as b. So in the general form of a linear function, it is always like that. All right? Now, this m is called slope. In class, I can use the decimals to demonstrate. So you could use decimals by yourself to see. Punch in all these numbers, different equations, all x to the power is 1, then you can see this is all a straight line. Every single graph is a straight line. And this m, when m changes, the slope of the line changes too. Now the slope is rise over run. So what does that mean? Is if this is a Cartesian plane, x and y, if this is a line, now this line, the rise over run is this m. Okay, the rise over run. B, Now B is called y-intercept. Why is y-intercept? Y-intercept means when x equals to 0. So for example, if this one x equals to 0, y equals to 5. So that means this graph will intercept with y-axis at 5, because at this point your x value is 0. This point x value is 0, y value could be 5. Okay, so now in this section 4.2, the task is to graph a linear equation, graph it. So graph it, I would introduce, there's two ways of graphing it. One way we called using a table of values. Table of values means I can let x be different value, and then y has different other values, and then I can figure out where my points are. Now x and y. So for example, now here, as I said, x can be any value, but y has to be accordingly. So, and also draw a line in order to graph a line, graphing a line. Graphing a line, you only needed to locate 2 points. 2 points make a line. So you wanted to locate 2 points on this line in order to draw the line. 2 points make a line. So, okay, I'm going to find my first point. I will let x be 0. If x be 0, okay, my y equals to 4. Wow, I already got 1 point on my graph, right? So then that is 1, 2, 3, 4. Okay, great, it's right here. And this is called the y-intercept to begin with anyways. And I also can say, okay, well, how about I let x be 3, because then my y will be a whole number. X be 3, so negative 4, and plus negative 2, plus, so if I say x equals to 3, so this 3 and this 3 cancels, that becomes negative 2. Negative 2 plus 4 is 2. So my next point is 3 and 2. So 1, 2, 3. 3 and 2. So my next point is here. Well, I got 2 points, and I connect this. And this is my line. Done. Okay. Another way to do it, the same question. Another way to do it is to use m, which is a slope, and use b, which is y-intercept. To graph this. So what does that mean? So my b is plus 4. So my b is plus 4, great. It's right here. I got myself a point. Right here. Okay? Now I have rise over run. So my slope now is negative 2 over 3. So negative 2 over 3 is either it's negative 2 over 3. So this could be right into either negative 2 over 3, or it could be another way to write is 2 over negative 3. Okay, so rise over run. So rise, if it's a positive, then you go up, right? If it's a negative, you come down. Run, if it's a positive, you go right. If it's a negative, you go left. So either this one, so I either use negative 2, so my rise is go down. So I go down, 1 and 2, so it's here. And then my run is positive, so 1, 2, 3. See, I ended at this dot. Anyways, and then that's my 2 dots, and then I draw this line. it has to be the same line because the same location, same equation. But if I say, okay, well, I want to do 2 and over negative 3, then that means 2 is to go right. 2 is going to go up 2. So 1 and 2 is over here. And the negative 3, I have to go to 1, 2, 3. Well, I have a dot here, but that is the same line. So if you got this dot and you have this intercept, you connected it, there's always the same line. So that is how we graph. And this is take some time to absorb and then take some time to practice. Now let me just show you an example. So here we're talking about graph. So this is your homework today. It's very important to do question number 8 and also question number 9. Okay, so let me show an example about question number 8. So now for example, this one here. I can use either table of values, okay? Table of values, x and y. So my x equals to 0, and then because there's a 0 here, then my y is 2. Now next time again and again, I'm going to use a 3, x equals to 3, so this 3 and this 3 can cancel. Negative 5 plus 2 is negative 3. Negative 3. All right, so then my graph is, oh, it's so bad. Negative 2, positive 2 is right here, and 3 and negative 3, so 1, 2, 3, and negative 3, 1, 2, 3. So then my next dot is right here. So here we go. And this is my line. Note, always use arrow both sides. That means the line is go forever. Okay, well, then I'm going to use another way to do. So it's my second way. My second way is I'm going to use the intercept. So that's my first point. Is my intercept positive 2, 1, 2, right here, positive 2. And then the slope is negative 5 over 3. So either it's a negative 5 over 3. So that means rise is down 5. 1, 2, 3, 4, 5. And then right run is 1, 2, 3. So right here. So then this is my line. See? These two lines are completely the same line. Now, next one is that write an equation for the graph. So how does that work? So now let's take a look at this. So this is 1. So therefore, my equation is mx plus 1, because this 1 is right here, this y-intercept. Now, how about what is the slope? Okay, I got to find the slope. So the slope is, okay, I'm going to put this point and this point, they're both on the grid, so I can count. So this is 1, 2, 3, see? No, 1 and then 2. So the slope is, rise is 2 and over 3. 2 over 3. They both, if I do a negative 1, means a negative 2 over negative 3. So my m equals to 2 over 3x plus 1. All right, so again and again, you need to watch this video very carefully. Watch it over again and again and try to understand what's happening here and do practice. And if you have questions, you may have to, you must come to class to ask questions. Thank you for watching.